Hello everyone. In this video, we will do some examples for probability trees. The first example is antibody test for COVID-19. I suggest that you pause the video here and read what is the example and then look for the rest. Okay, so there is a test which detects if a person ever had the infection. Now, we know that these are the information for the test, that the chance that the test will come out positive for a person who had COVID, so this is COVID, then positive comes out, is 90%, or in other words, 0.9. Well, that means that the result will come out negative for such person by chance 0.1. And furthermore, we know that the probability of the test being positive for a person who never had the COVID-19 is 0.05. Well, that's a error for the test, but there is a chance that you get that, and this will be 0.95. So that's basically what we have for the tree. But then we focus on a specific city in which 30% of the population has or had the COVID-19. So this is 0.3 of the population had the COVID, and that means that 0.7 will be there. Nice. The tree is complete now. We can use it, and the question asks, what is the probability that the person's result will come up positive if the person is from this city? So we are looking for probability of positive, and as you see, there are two passes here, and which end to P. This is one, the other one is that. Okay, so for each path you have one probability. You multiply the probabilities along the way, and that is for the other one, and then add them. That's the rule we have here. Yes, so this was 0.27 plus 35, 0.035. That's important to see. And now if you add them, it is 0.305. So in other words, with the probability, 30.5% of the time, the test will be positive. And as you can see, it is more than the actual percentage of the population who had COVID-19, and that's because of the error that we see in the test. Okay. Well, that's the first question. The second question is that there's a box which contains 4 red balls and 2 black balls. The balls are drawn randomly without replacement. If it was with replacement, then the story would be different and would be easier. Actually, we will get back to these kind of questions later for cases that there is a replacement there. But for this one, okay, so I first draw the first ball. It's either black or red. The chance that in the first draw the black comes out is there are 2 out of total 6 black, so 2 over 6, which is 1 over 3. Let me write that. And for red is 4 out of 6, which is 2 over 3. Well, then we can continue. Well, if the black comes out, it's done. We cannot do anything until the black ball comes out. So If the red comes out, on the other hand, we can continue drawing balls. In that case, since already one of the balls are taken out, is taken out, so there are total 5, 2 of which is black and only 3 is red. For the third one, so again we can get either red or black, and while there are only 4 left, 2 of them are black, so half of it black and half of it red. So the chance that we get out red is half. Now you see that if black comes out, I don't grow any branches on that, on those parts. You see, that's the stop point. However, when red comes out, we can continue and do a little bit more. So here there will be only 3 left, of which only 1 is red, and well, 2 out of 3 will be black. Then the last draw, there is no red ball left, and black ball will come out definitely. So this will be 2 over 2, which is 1, or 0 over 2, which is 0. So that's the tree. Now, what is the probability that the third drawn ball is black? So third is black. Okay. For that, you see that the third black, this is first one, second one, and third one. This is the end point or terminal point, and that's the only terminal point, which means the third drawn black ball is black. So that means that the probability of that is equal to the product of the probabilities along the path. So this is that. Yeah. So as you see, this cancels with that, this cancels with that, and the remaining is 1 over 5. What will happen for this case? So what if we are looking for the probability that black is not drawn, or first 2 are not black? That's one way to write that. So in that case, so basically we are trying to find this one here, this one here, or this one here. Either the third one is black, or fourth one is black, or fifth one is black. Then you can see that there are 3 endpoints. You go ahead, multiply, find the probability of paths, and then multiply them. So that's one way to do it. So I will do that one first. Starting with the third one, half times 3 over 5 times 2 over 3, plus 2 over 3 times half times 3 over 5 times 2 over 3. And the last one is 1 times 1 over 3 plus, times probability of a path is always product entries on or along that path. Okay. So as you see, well, the first one is going to be 1 over 5 plus the second one, this cancels with that, this cancels with that, and then the remaining is 2 over 15. The last one, this cancels with that, that cancels with that, and then the remaining is 1 over 15. So as you see, then this number is 15. Well, there will be 3 there, there's 2, then 1, 6 over 15. This is 2 over 5. And 2 over 5 is the probability that the the first two is not black. There's also another way to compute this one, which is the probability of first two are not black is the same thing as 1 minus probability of either first or second is black. So if you're trying to compute that one, you'll notice that, oh, there are two passes, either that or this one, which will end up with that case. So 1 minus, the first one gives me 1 over 3. The second one gives me 2 over 5 times 2 over 3. And let's see if we get the same numbers or not. Here is, okay, I take common denominator 5 plus, that is 4. And that will give me 1 minus 9 over 15, which is 6 over 15, and that's 2 over 5, as we were expecting, and we got that from a different method. So this is alternative way of finding that. Okay. So these were examples, and you see, once you set up the tree, then the rest is very easy when you're dealing with the stochastic processes.